Hey, I wanted to make just a quick video about array programming in Fortran. Today I saw this video from Code Report about the state of array languages in 2024, and he made this comment in the beginning of the video that he was just going to talk about modern Iversonian array languages, which would not include Fortran. And then when I went to the comments, I also saw this, this user was asking a little bit more about Fortran array programming. I just want to talk about the ways that Fortran really is an array language. Fortran as a language wants you to work in arrays and matrices as much as any other array languages that I've used. So the first example is really quickly what it looks like to construct an array in Fortran. It looks almost identical to a list comprehension in Python. This is called an implied do loop because there's a do loop that you're not spelling out, it's implicit. And these can be really complicated, so they can be nested. And for example here, for every element from 3 to 6, we give that element and its square. So these can be really powerful for describing array constructs in really terse notation. And then working with shapes is really, really easy, just like NumPy or BQN or some other array language. You can get the shape, you can query the shape really easily. You can give an array or matrix a new shape. You can also give a second array to be used for padding if you try and reshape something to a greater size than the number of elements you pass in. So for example, here I try to create a 3x3 matrix out of only 3 elements, and then I use another 3-element array, 4, 5, 6 at the end, to pad in the end of this 3x3 matrix. That's just like in BQN or something, you might extend a smaller vector into a matrix by reshaping it and backfilling with the same array. You can do the same thing in Fortran. Deshape in Fortran is spelled pack. It works just like in BQN, except it is overloaded with a little bit more meaning. So in this example, we just take a matrix that's 5x3 and deshape it into a 15-element list. And this second argument here is a mask. So I can just give a scalar to deshape every element in the matrix. Or we can also give it a condition. So here I create a mask. So we've got a 3-element array and I unpack it into another 3-element array. So the pack intrinsic in Fortran doesn't just deshape, but it also can filter and replace values. So in this case, the 0 of iota gets filtered out and we pull the last element from the fill array at the end of this pack call into the output array. Masks are also really foundational to Fortran, as we saw in the last example. Here we use a comparison operator with an array to get a mask for the entire array. So now D is an array of the same rank and shape as C, except it's true where all of the elements of C are greater than 0 and false otherwise. One of my personal favorites is the where statement in Fortran. These can be much more complicated as a simple example, but we can assign to an array of any rank where its elements meet certain criteria. So for this example, all negative elements of C are set to 0, sort of like a clamp function. We can also assign to C such that all the negative elements are replaced by their corresponding element of E. This is a really simple one-line statement, but it's a perfect example of how Fortran really wants you to build your program out of arrays and matrices. Elemental functions are really special. They work automatically on arrays of any rank. So this multiplies every element of the input array R by 2, no matter the rank of the input array or even if it's a scalar. And it's really easy to specify purity, which means that there's no side effects of this function and it's rank agnostic. As an example of the elemental function, here we have a rank 3 matrix that we'll pass in. So this is a matrix from 1 to the product of 3, 4, and 5 of shape 3, 4, and 5. And then we can apply our elemental function to double every value. Here's another example of how you can really elegantly express this triply nested loop in C with this elegant and simple expression in Fortran. This is a little bit of a tangent, but all the built-in operators automatically know what to do with arrays, just like in BQN, for example. And plenty of intrinsics like sum let you work on arrays really easily, like you might expect. And there's also built-in parallelism support with, for example, do concurrent. It makes it easier for your compiler to generate parallel code for loops. For example, here's a triply nested loop reduction that sums the values of the matrix together. And many Fortran compilers can automatically use all of your CPU cores or even your GPU for something like this. This is another little tangent, but the aliasing rules in Fortran are really, really conducive to array programming as well. With this example in C, the compiler can't vectorize this loop because in C, the pointers A and B are allowed to alias each other. They're allowed to point to the same chunk of memory possibly. But in Fortran, this is not allowed. So if a function or subroutine is passed to arrays, the compiler is allowed to assume that their memory doesn't overlap and it can generate vector instructions for something like this, which means Fortran can generate array code at the assembly level. Now, if we go back to C for a second, we can modify this function on the screen right now to tell the compiler it's allowed to vectorize this loop, but not many programmers know to do this sort of thing, and it's not a part of the language in the same way as in Fortran. So we can use this restrict keyword to tell the compiler that A and B point to non-overlapping segments of memory. But again, not everyone knows to do this. So there are also all kinds of libraries and programs that already use Fortran that you might not be aware of. For example, if you ever use SciPy in Python, then you're already using Fortran. And that's really all I wanted to say for today. But thank you for listening, and I suggest you go try out Fortran in Compiler Explorer, or maybe try to solve some LeetCode problems with it and see what you think. Thanks, have a good day.